Hello guys. So now as you can see, we will discuss about why do stars twinkle and planets don't. So we had a discussion about this, that we will discuss about the practical application of refraction and how to understand those much carefully, much neatly, that means with the diagrams. So our first question was stars twinkle, planets don't. Okay, so some of the planets we can see from by our naked eyes when it is very close to us, but stars, whatever we see, they are not very close to us. Obviously they are very much away from us and they do twinkle. Now why do they twinkle? Now here is a star and here is your eye. Okay, so you have to understand the path of light it follows while that light from the star comes to your eye. So that path will decide that whether you will be able to see that one or you will not be able to see that one. First of all, we also have to understand that what is twinkling. Twinkling is, my dear friend, one is you can see that sometimes and you cannot see that sometimes. That is twinkling. That means on one moment of time you are able to see that star and at the other you are not. Which means the light is not coming for a moment and then it is again coming. So how it is happening? Now these stars are very much away from our eyesight. Okay, they are very much away. The distance between the star and us is very far. So as the distance is very far, there is many layers of atmosphere that is lying between the star and myself. So as there are many layers of atmosphere, there is change in density of that air in those many layers. So as we go up, it is becoming lighter, that is less dense. Okay, this is becoming lighter. So this is the most dense part. Okay, this is the most dense part in this total layers of the atmosphere. So if you see the light coming from the star over here, it is like this. So suppose a light, so I am considering density change in this along this line. So that light is hitting the surface or the interface between two densities. So there I draw a normal. It comes closer to the normal because it is traveling from lighter to denser. Lighter to denser jane se it comes closer to the normal. Again it comes more closer to the normal. It comes more closer to the normal. Finally it reaches my eye. Now my eye will always see it in a straight line. So the apparent image of this star is formed over here. So I can see this star over here. I am not seeing it at its actual position. I am seeing it over here. Now, as the distance is very far, there are a lot of density intermixing between the atmosphere that is going on. And the size of the star is very less. So as there is a lot of density intermixing that is going on, so this refraction, whatever you are seeing, when your eye is at this position, it may not reach over here because the densities are changing all the time. There is intermixing. Some densities will move there. Some molecules are moving there. Some molecules are moving there. So the speed of the light is not becoming constant at any moment of time when you are considering so many layers of atmosphere between myself and that star. So as there are so many layers of atmosphere and the densities are continuously changing over here, so sometimes my eye is over here, so I am being able to trace this light ray, and sometimes it may fall like this also. So it will not come to my eye. So my eye will see nothing. At that moment of time, I see nothing. Again, I see something. Again, I see nothing. So this is twinkling. Now, we understand that what is twinkling of star, but we still do not know why doesn't planet twinkle. Planet is much more closer than the star. So the size that we see of the planet is also large. So if you see this one, it may have one refraction like this. And here is my eyes here. So I will be able to see, even if a little bit of density changes, it may change very slightly. But here even a little bit of density change may happen like this. It is coming like this, then like this, then like this, and you don't have your eye over here, right? You are having your eye over here. Okay, but here there are many less amount of layers between the planet and the eye. So even if some amount of density changes, it seldom falls away from our eyesight. So that is why stars twinkle and planets don't. Hopefully you have understood. I know everybody, most of you are going to write an answer that is written in your book in toto by learning it by heart. But that will not help you. This diagram is must. You want to score good marks, this diagram is must. This will give you an edge over the others. Okay? So, obviously draw this diagram, this one, why do stars twinkle, so that they have an idea that yes, you have understood. The teacher also has to know that you have understood the concept very clearly. So, I am just repeating it once again. There are many layers of atmosphere between the star and your eye. So in the layers of atmosphere there is refraction and the light reaches our eye. As there are many layers of atmosphere between our eye and the star, so there are some density changes that are going on, which makes the refraction go in a different direction, or which makes the light go in a different direction due to different refraction. Okay, so the light ray will go in a different direction. As the optical densities of the atmospheres will change, so the layers of atmospheres will change, so it will go in different direction. And as soon as it goes in different direction, the light ray coming is falling outside my eyesight and I am not being able to see. So, there are many layers of atmosphere, there is change in optical density, light will be moving from one place to another, it will not be following a single path, the path of the light will be changing due to change in optical densities of so many layers of atmosphere. So, the stars will twinkle as sometimes light will come to my eye from the star and sometimes it won't. In case of planets, it is much closer to our eye. Number of layers of atmospheres is very less. The change in optical densities happens, but as the number of layers of atmosphere is very less, so the effect is not that much and seldom lose the sight of the planet in our eyes. Thank you.